I've been using the NZXT H1 for about 8 months now, something to tinker with during the pandemic. I've even designed a custom front panel for it, which has been quite successful with the community over on Reddit. I've been pushing the case to the limits, especially with the Nvidia RTX 3080 Founders Edition. But ever since I've seen the Watercooled H1 build by Optimum Tech, I knew that was the way to take this build to the next level. There's just something about cooling a powerful system with a single fan. The centerpiece of the build will be the EK Special Edition 3080 water block. It's beautifully machined, it's really heavy, and personally I think it looks even better without RGB. Initially, I wanted to go with thinner tubes, but that just wasn't working, especially with the very tight bends that are needed inside the H1. I tried two different tubes, the Tygon A-60-G, as well as a PVC tube from Alphacool. Compared to the EK Zero Maintenance 16mm tube, the difference is massive. The thicker tube allows for much tighter bends. It's a little bit harder to work with, but it's well worth the compromise. The 3080 block features ports to the side, and with some 90-degree fittings, we can have a splitter at the highest point of the loop. This makes it really easy to fill and drain the loop. I need to stress that most of the homework for this build has already been done by Optimum Tech, so I'll have a link to his video in the description below. Let's have a look at some thermals. Running the CPU with PBU enabled at stock settings, we get an 80-degree max after 2 runs of the Blender benchmark. By using an all-core overclock with a much lower voltage, we can drop our temps by 12 degrees, and we're actually gaining some multi-core performance. For an apples to oranges comparison, let's have a look at how the 3080 cooler compares to the custom loop. Not exactly a fair comparison given the poor performance of the flow-through cooler in sandwich style cases, but it's still interesting to see a drop of 15 degrees. After 5 runs of the Port Royal benchmark, we have a max of 59 degrees. Similar temperature maximums are reached by running the RTX boundary benchmark. Generally, temperatures tend to stabilize around 60 to 61 degrees on the GPU. I am running the GPU with an undervolt of 856 mV, which drops the card's power draw by about 100 watts, for little to no performance loss. What I would like to see is how the system does under a sustained CPU and GPU load. The perfect tool for this scenario is Cyberpunk 2077. I'm running it here with ultra ray tracing, DLSS performance, and some optimized settings. As we can see looking at the numbers, by running the CPU with PBU enabled, we're reaching a toasty 81 degrees on the CPU. Switching to the all-core overclock, we can actually drop the temps by a massive 15 degrees. I've also ran the same test using the stock tempered glass panel, and surprisingly we're only seeing an increase of about 2 degrees. Running a lighter load, such as a 60-minute session of Destiny 2 at 4K, we're seeing much lower temperatures across the board, and by using our low voltage overclock, we're able to squeeze both the CPU and GPU right under 60 degrees. I've run all the tests here with a fixed 1250 RPM on our single 140mm fan, so the system is actually surprisingly quiet. One more thing that I would like to cover in this video is a fantastic piece of software called Fan Control. This allows us to control our single fan based on the GPU temperature reading. This way we can have the fan only ramp up when the liquid in the GPU block starts to heat up. Without a dedicated water temp sensor, this is the next best thing. I've really enjoyed working on this build, and the results are indeed surprising. With some undervolting, I would say that it's definitely viable. Thank you so much for making it to the end of this first video on my channel. I do plan to have regular content going forward, so if you're interested, don't forget to subscribe.